A warm welcome to all the viewers for the course Strength of Material, AME 302. Myself Thiyapal, Assistant Professor of Department of Mechanical Engineering, and today I am going to discuss the topic that is elongation of the bar, which is basically included in the module 1 of Strength of Material for the course AME 302. So this is probably the third part of the elongation of the bar. Because this elongation of the bar, it is basically consisting of several different criteria. That is how the elongation of the bar is occurring for various type of condition. So initially in the part 1 lecture we have studied if it is the bar, it is having the coaxial load and it is placed horizontally position, then what will be the change in length or elongation of the length of the bar will occur, we have studied. Then in the second condition we have studied that if the bar is taper section, means one end it is having a smaller diameter, other end is having a bigger diameter. In that particular condition, how you are going to calculate the elongation of the bar, that also we have studied in the part 1 lecture for elongation of the bar for module 1. Then this lecture was followed by part 2 lecture where we have already studied that what will be the elongation of the bar if it is facing its own weight or considering the elongation of the bar under its own weight. So the bar has been placed in a vertical position where one end of the bar is fixed, other end it is free. So what will be the elongation of the bar if you are implementing the load P in that particular section? And next we have also studied about the thing that is if it is having a various section, then what will be the change in length that will be occurring for the total bar. So you can see that already in this 2 lecture I have already covered up that elongation of the bar for various object or various bar, it is getting change. Why? Due to the presence of parameter, various parameter. If the area, diameter, length all are varying, then there will be different section. For taper, the elongation of the bar is something different. For normal bar, if I am considering a cylindrical bar with axial load of P, then you are getting some different section. So you can see what are the changes that are there associated with. Now today in this particular lecture of elongation of the bar, that is part 3 lecture, we are going to discuss if the load is getting varied, then how we are going to calculate the elongation of the bar. That is, if the load, it can be tensile, it can be compressive. So previous lecture have already covered up that we are dealing with one type of load, either it is compressive or it is tensile. Basically we have dealt with tensile load, but today in this lecture I am going to cover up if you are varying the load, that means the load, it can be tensile, it can be compressive. So in that particular situation, what will be the elongation of the bar that we have to calculate. So without any further delay, let's have a look at the content. So in the content, initially you have seen that we are using change in length due to axial load. I have covered up elongation of a taper rod under the action of coaxial pull. It has been also discussed. Next, in the second lecture, I have discussed elongation of the bar under its own weight and bar of varying section. But today we are going to consider compound bar with initial weight, and we are also going to solve some numerical. So compound bar with initial weight, it is what? That is, you are considering a bar and it is the material is different. And the thing is that it has got some initially weight also. So in that particular section, how it is you are getting the change in length for that particular type of task. Again, bar of varying section, when we are talking about, there also you can see that already you have received a bar where you have already implemented only one type of load, that is tensile load. But if that same particular bar you are using, and there you are using various types of load, it can be tensile, it can be compressive, in that particular situation how you are going to calculate the change in length for this particular portion. So you have to consider this thing also in today's lecture. So without any further delay, let's have a look in the next slide. So in the next slide, what we are able to see, that is, we are going to make the determination of the increase or decrease in length of a bar subjected to an external load at the end and also in some intermediate sections also. So you can see this is a complete bar. This is a complete bar. So if you name it, this bar as 1, this bar as 2 and this bar as 3. Okay. Why I have mentioned it 1, 2 and 3? Because you can see the length of different section has been different. That is L1 for bar 1, L2 for bar 2 and L3 for this bar 3. And you can see various types of load has been given here. What are the various type of load has been given here? P1, P2, P3 and your P4. So you can see various types of load has been also mentioned here. P1, P2, P3 and P4. Now the thing is that ultimately we need to know what is the elongation of this particular bar we are going to determine. Now if you have a look here, that is, in case of P1 you can see that is the load has been given tensile. But if you look at the portion P2, you have to see whether it is tensile or it is compressive. If you consider that particularly bar BC, then can you tell me in that particular bar BC whether the load will be compressive or it will be tensile? It will be difficult for you to determine. But yes, there is some method through which you can calculate. And next, finally, what you are seeing, that is bar 3, that is CD. The load P4, can you tell me whether it is tensile or compressive? Because if you consider the bar CD, on the right hand side you can see the load is tensile and it is determined by P4. But at the same time, if you have a look at the C portion, then you can see that P3 is different load, and what you can see is that the load has been given a load of tensile, that is of P3. Now you have to calculate in what respect you are calculating it. So first thing you have to do is that to solve this type of problem you have to see whether the load are in equilibrium condition or not. That means you have to make a summation of all the tensile load, or at the same time you have to sum up of all the compressive load, and you have to see whether the value is equal to 0 or not. So if it is getting all the load summation is getting equal to 0, that means it is in equilibrium condition. So you have to see that whether algebraic sum of the thing is in equilibrium or not. First step is to determine whether A, B, C, D bar is in equilibrium condition or not. Now you have to treat one thing, you have to consider, that is, if the portion is found to be in tension, then the deformation is always treated as positive. But any portion, if the load is compressive, then the deformation has to be treated as negative. So this is the basic consideration that you have to keep it in your mind. Again I am repeating, for any portion, if you consider that there is some tension load is there, that means the deformation will be treated as positive. Or in any section, if the load is compressive, then the deformation that is occurring, it will be treated as negative. So here you can see that various sections have been given there. So how you are going to calculate it? First concept I am telling you, you have to separate the bar separately. That is, you have to make the bar separately. So what you are going to do, this is your bar 1, okay, this is your bar 2 and this is your bar 3. This is your bar 1, this is your bar 2 and this is your bar 3. Now you have to determine whether the load will be compressive or tensile. So initially you are starting with P1. So P1 is your tensile. So if you consider P1 as tensile, that if this side your load is P1, it is tensile, then this side also the load will be tensile. Now P2, if this is tensile and this is tensile, then you have to see if this portion is tensile here. Now this force is exerting here in B as compressive, but this portion at B is considered as tensile. So you have to see whether the load is tensile or compressive, and on that particular basis you have to make a summation. If both load are tensile, then it will be added and you will get a new data, and if the data is in positive mode, then you have to treat that load as positive. You have to treat that as positive. So if your second portion, this surface is treated as positive data, that means this portion will be also treated as positive data. And next, in the third case, you have to see that here in this third case, that is third bar, you can see here the load is tensile, and for BC when you have considered the bar 2, here also tensile. So both tensile load are acting in this particular plane C. That means 2 tensile load are acting, means 2 are positive. So after getting summation, if the result is positive, then the load for this third section, this is also positive, and for this section it is also positive. So you can see 3 section, 1, 2, 3, all are positive. If all are positive, the load are positive, then this load is treated as tensile load. But if the result you have got in negative, for example, you just consider, for one case you have got both the side tensile load, but for B section you see here is a compressive load that is acting on the surface B. In the same way, in this B surface, if you consider AB bar, here you have received a tensile load. Now if the compressive load is greater than tensile load, then if you sum up both the load, you will get a negative load. Suppose your tensile load was 4 and your compressive load that is acting at point B was 6. So compressive load 6 means it is minus 6, and tensile load at B for one bar it is 4, that is it is plus 4. So if you sum up both 4 and minus 6, you will get minus 2. So you need not need to write that minus symbol. You need not need to write the negative load there. Only you have to consider that negative means it is a compressive load. So in case of 2, you will be observing here there will be load will be in reverse direction, that will be in opposite direction, in compressive mode. Here you have obtained the tensile, that's why you have given positive. But if you have obtained some negative load result, then here in this particular situation you have to provide a negative load, that is your compressive load. No negative symbol will be included. Now in the third case again same thing, you can see that here you have got a tensile load, and suppose in BC section you have got some compressive load. Now the compressive load you have got 2 value, but here you have seen that for 3 the load is of 4 value. So this tensile load is much better than your compressive load, and compressive load means negative load. So if you sum up the negative load and positive load, then you will get a positive value if the value is greater for positive load, because in compressive load you have got negative value of 2, But in the bar 3 for the plane C, you have got what? You have got a positive value of 4. So plus 4 minus 2, you are getting plus 2 result. So this plus 2 means it is a positive load. So here for 3 you have written tensile, you can see. Now you have to remember one thing, that is, if the load is having positive value, then the change in length that you are calculating, it will be also of positive one. But if you are using compressive load, then there is a decrease in elongation. It is not increased in elongation. So if it is decreased in elongation, that means automatically the elongation will be in negative mode. So when you are calculating the elongation for the entire bar, that is del L is equal to del L1 plus del L2 plus del L3. Now this del L2 will be no more plus value, it will be of negative value. So if I ask you the total change in length for this particular bar, then you have to write in this way, del L1 minus del L2 plus del L3. Now this minus you are calculating when you are performing the numerical, but initially you have to write as positive for the equation, because total change in length or elongation is length has been considered as summation of all the elongation for various bar separately. So if you are using tensile load, your elongation will be considered or treated as positive. If you are using compressive load, your elongation will be treated as negative. And if you are again using the elongation and where you are using the tensile load, your elongation will be treated as positive. So when you are particularly sum upping the thing, so tensile positive, for compressive load your deformation will be negative, and for tensile load again the deformation will be treated as positive. So you sum up all the thing, then you can get the entire value for the elongation in length. Hope it is clear through this particular figure. We will be discussing with the numerical, the concept will be much more clear to all of you. Now just have a look at this particular portion. In this numerical you can see MS bar has been considered, which is of 30 centimeter long, and you can see the value for L1, L2, L3 all are basically same. So L1 is equal to L2 is equal to L3, and you can see this 3 section, that is AB is one bar, BC is another bar and CD is another bar, and the cross sectional area of the entire bar is 4 centimeter square. So the area of the entire bar has been given to you because the diameter is same, and you can see the material is also same. That's why the modulus of elasticity or Young's modulus value has been given as 200 kilonewton per millimeter square. So you are very sure that value for E is same for the entire portion because the material is same, and the length is same, the area of cross section is also same. Now what you have to do is that you have to see whether the body is under equilibrium or not. So you can see how many tensile load is there and how many compressive load is there. So if you see the tensile load, this 50,000 Newton, this is tensile, and this 20,000 Newton, this is also tensile. So summation of these two tensile you can see, and this compressive load, basically they are negative load. So you can see compressive load is 50,000 Newton and this 20,000 Newton, these both are compressive load. So both are having summation, since they are negative compressive load, that's why you have used the negative sign here. So that's why 50,000 plus 20,000 tensile load, if you are adding the compressive load, the negative value for 50,000 and 20,000 compressive load, the summation that you have achieved is your 0. and that's why you can say the body is in equilibrium. So now you can solve the numerical. Now just have a look at this particular section. Again what you have to do is that you have to name this bar. Consider this as 1, consider this as 2 and consider this as 3. Okay. So in first case you can see, the load has been given you tensile load of 50,000. So for A calculation it is 50,000 tensile load. So if you separate this one particularly in another way, this is for your bar 1, okay, this is your bar 1 if you are considering. Then what I have told, 50,000 is your tensile load, 50,000 this is tensile and this is also tensile. So 50,000 is a tensile load. Now consider this bar 2. Now bar 2, if you look at the surface B here, you can see that here the load that has been given is compressive. How much compressive load? Of 20,000 Newton. But if you consider the object AB, then at B portion for AB you can see there is a tensile load of 50,000 Newton. So if I tell you the tensile load of 50,000, that is positive 50,000, and here you can see compressive load of how much? 20,000. So if I give here minus 20,000, then if I tell you make a summation, then what you will get? A result of 30,000. And this 30,000 is what? This is your positive. This 30,000 is what? If you consider this 30,000, this is as positive. If positive 30,000, that means this is a load of tensile load you have gathered. So B and C portion, again if you draw a bar, B and C portion, what you will be getting? This is also you will be getting a load of tensile load. This also you will be getting a load of tensile load. So tensile load is of how much? Now 30,000. So for this bar 2 you have got load of 30,000. And here you have got for bar 1 of 50,000. Okay. In the same way, if you consider the bar 3, now just have a look here. For bar 3 if you consider, then here what you have seen, a tensile load for C section has been considered as 20,000. And if I consider BC bar, then here you are getting also a tensile load of 30,000. So for third number case, what you are getting? A positive of load of 30,000, and here also you are getting a positive load of how much? 20,000. So all total what you are getting here is that all total you are getting a load of plus 50,000. So this 50,000 is what? This 50,000 is your positive load. So that's why it is your tensile load. It is your tensile load. That's why in the third section, if you draw a third section, here you can see tensile is there. So here also 50,000 is there. So you can see that how basically you have calculated the load for 3 different sections. And if you have completed the task of calculating the load, then I must say it is very easy for all of you to calculate the change in length or elongation in length of this particular bar, because you have obtained all the load are in tension mode. For bar 1 the tensile load is of 50,000, for bar 2 the tensile load is of 30,000, and for bar 3 the tensile load is of 50,000. So since all the load are in tensile mode, therefore your elongation of the bar, it will be also in tensile mode, because the elongation of the bar will be in positive mode. So you need not need to worry. You have got the load, you know the area, you know the value for modulus of elasticity. So if I ask you what is the change in length, then it is written as P into L by A into E. So P means for bar 1 you are using 50,000, length you are using 10, and you are using area that has been given for the entire section. So when you are using for the entire section, the change in length, what you have to do is that you have to make a common area from the entire formula. So if you use del L, that is equal to del L1 plus del L2 plus del L3, and this del L is what? P into L by A into E. So what you are going to do is that for the entire section, A by L, P into L by A into E, what you have to do for the entire section, L by A you have to take common, and in bracket you have to write P by E. Okay, P is also, E is also same for everyone. So what you are going to do is that L by AE you have to take it common. In bracket what you have to do is P plus P plus P, you have to go through it and you have to calculate it so that you can get the original result. So you see the numerical that I have solved there, 50,000 is there, 30,000 is there, and 50,000 is there. So separately you have calculated del L1, del L2 and del L3. Since all the value you have got in positive, because your load is itself positive, that's why you have got all the elongation as positive. So what is the total elongation in length? That is del L1 plus del L2 plus del L3. That will help you to get the summation, and you have finally got the result as 0.01625 centimeter. So this is the simplest numerical that you can go through to calculate the elongation of the bar. Now this is none other than everything the same thing. Now we are talking about the compound bar with the initial weight. So this is one bar, this is another bar, and it has been attached with weight W. This is one of the figure, and you can see there are two different material. This is one type of material and this is another type of material. This is the same type of material, but in between this is another type of material, and they have been compactly made, and it has got an initial weight of W. So in these two different conditions, how you are going to calculate the elongation of the bar? Very easy. Now this W, this weight is what? Weight of bar 1 and weight of bar 2, that has been given, weight of bar 1 and weight of bar 2. And what is the formula for weight? That is force into area. So weight can be also written as force into area. So you can see for these two figure, you just consider A1 as area of the cross section of the bar for number 1 bar, A2 is the cross sectional area of a bar number 2. Modulus of elasticity, since we are using different materials, so modulus of elasticity for bar 1 is considered as E1, and modulus of elasticity for bar 2, it has been considered as E2. And stress will be also evolved different because both material are having different modulus of elasticity. It has got different weight, it has got different diameter, it has got different stress involvement too. So for that stress 1, F1 has been considered for material 1 or sigma 1, and for 2 it has been considered as F2. So you can see the various value it has been given here. Now how you are going to calculate? Again the same formula, strain. Strain is known as change in length by original length. It can be also written as stress by modulus of elasticity, because modulus of elasticity, if we see modulus of elasticity, capital E, it is denoted by stress by strain. So that only they did. So if stress by strain is there, then you can write strain can be also written as, or the strain can be also written as F by E, that has been provided here. So in the same way, this is for bar 1, and this has been strain 2 is calculated for bar 2. So whatever may be the object, it has been attached with a single bar and it has been shown that it is hanging there. So you can say that the elongation of the bar that you have obtained here, it is also getting what? Equal, that is strain in bar 1 is equal to strain in bar 2. So if you write this one, then you can write F1 by E1 is equal to F2 by E2. From there you can write F1 by F2 is equal to E1 by E2. Now if I talk about the load P1 for B1 bar 1 and P2 for bar 2, then total load is summation of P1 plus P2, and P can be determined stress into area plus stress into area for this 2 bar. So finally what I have told that F1 by E1 is equal to F2 by E2, which is also written by F1 by F2 is equal to E1 by E2. And then the same numerical you can see here, same concept, that is bar, this is brass and this is steel. So weight has been given as 30 kilonewtons. So this weight is of what? Bar 1, bar 2 and bar 3. And modulus of elasticity is different for brass and steel because they both are different material. One is brass, another is steel. So what you have seen, that is 2 brass rod is there. So I can write 2 WB plus 1 WS is equal to 30. So 2 WB means what? 2 into stress into area, and for steel stress into area, that is equal to 30. Now area, it is known to you. So pi by 4 into d square. You have got the area for brass also, for steel also. Now the diameter is same for both the section. So after putting the value of the area, you will be able to calculate the value for stress for brass as well as stress for steel. So again I know that stress for steel by modulus of elasticity for steel is equal to stress of brass by modulus of elasticity of the brass material. So you know you are getting a relation of stress for steel along with stress for bar. Now if you put the value of this particular thing, F's value will be put in respect to FB value, then you will be able to calculate the FB value. And if you get the value for FB, then it is very easy for you to calculate the value for what? WS, weight of this one. So in this way you have got all the value for your weight of the brass, length of the brass, it is known to you, area of the brass is also known to you. So if I ask you what is the change in length for the brass rod, then you can say change in length is equal to load into length of the material into area of that material into this modulus of elasticity of the material. And you can see that this is the proper calculation that you have calculated, and finally you have obtained the result. So finally we came to the end of this particular lecture, and in this particular lecture I have told you how to calculate the elongation in length if you are using various type of load. The load can be tensile, the load can be compressive. Only the thing is that if you are using tensile load, the deformation that you will be getting in the length, it will be treated as positive, and if you are using the compressive load, then the deformation of or you can say the elongation of the bar, it will be treated as negative. So ultimately whatever may be the bar, you are using a composite bar, so you have to calculate the elongation separately for bar 1, for bar 2, for bar 3, and if it has been asked to you to know that what is the total elongation of the bar, then nothing you have to do, only you need to do the summation. Now this elongation can be positive, or you can treat the elongation as positive if you are using tensile load. Even you can treat the elongation as negative if you consider the compressive load. Only this thing you have to consider in your mind. So you have to be very sure that whether and how you are basically dealing with this particular portion. So if you have liked the video, then please stay connected with me and follow my channel, so that in the upcoming video we can have a brief discussion about all the biaxial stress, principal strain, and we are going to discuss about the Morse cycle, how you are going to draw the Morse cycle, which one you are going to consider as that principal plane. Everything will be discussed in my next lecture. Thank you for watching the video, and if you have liked the video, then please like the channel and subscribe my channel, and please stay connected with me. Thank you viewers for watching the particular content of this video. Thank you very much.